Hi guys, today I'm going to present a video on retaining walls. Introduction. Retaining walls are built to retain the filled earth of greater height. They are commonly used in railways, road projects where earth filling is required to maintain the track or road level, especially in the approaches to bridges. In buildings also, if basements are provided, retaining walls are required. Wing walls and abutments of different structures like single lane bridge, double lane bridge are also acting as retaining walls. To release the unnecessary water pressure building up during rainy seasons, weep holes are provided in the retaining walls. At the top on backfill and in front of the retaining wall, the longitudinal drains are provided to drain off the water. Backfilling near retaining walls provided with broken stones, gravel, or sand so that the drainage in the longitudinal direction is improved and water pressure on the stem wall is reduced. This is the typical cross section of the retaining wall. This is the base slab, and this portion is toe, and this is heel, and this portion is stem portion. Actually, the gravel or sand filling is provided to reduce the pore water pressure which comes out through weep holes and collected in this drain and which will be disposed of. This is the backfill, that means the earth is filled in this particular portion, and whatever the water comes in the top of the retaining wall which will be collected in this drain. The types of retaining walls. Firstly, gravity retaining wall, cantilever retaining wall, counterfort retaining wall, and finally buttress retaining wall. In this video, I am concentrating on cantilever retaining wall and counterfort retaining walls. Why? Because for JNTU students, the cantilever retaining wall and counterfort retaining wall design is incorporated in their syllabus, so I am concentrating on these two retaining walls. In cantilever retaining wall, stem, heel, slab, toe slab, all acting as a cantilevers due to pressure from the backfill and soil pressure. Generally, these type of cantilever retaining walls are economical up to a height of 6 to 7 meters. This is the typical cross section of the cantilever retaining wall. As I already told, this is the toe slab and this is the heel slab. Totally it is a base slab, and finally this is the stem portion which transmit the load of earth to the base slab. This is the ground level, this is the earth fill level. In counterfort retaining wall, the counterforts are provided at regular intervals to strengthen the stem wall. In this case, heel slab and stem act as a continuous slab, but toe slab will act as a cantilever. These are capable for retaining earth to greater heights. Actually, these type of retaining walls are economical when the height exceeds 6 to 7 meters. The counterforts are provided at certain intervals. Actually, in this diagram, the counterforts are provided at certain intervals which will support the heel slab and stem. So stem and heel slab act as a continuous, but toe slab act as a cantilever. Thank you. Thank you for watching. Please subscribe for new updates. Thank you.